Hello and welcome to the Swings container section of the course. As you will have heard me mention many times throughout the course, swing is very hierarchical. In fact, it's the whole concept of swing is to be something inside something inside something inside something. And containers go a long way to achieving that. So let's get started with the presentation. Swing provides top-level containers. There are, generally speaking, three. Two of which, if you've ever used any form of Windows, which I'm assuming if you're now trying to program in them, you have, there's the frame and the dialog. The frame is the top-level window. Typically, it's got the title bar, maximize, minimize, close, buttons on it, and that's the frame. It's what contains the application. You get dialogues, we're all familiar with them. Maybe when we delete files, it comes up and asks for a confirmation. It puts a little window up and asks for a confirmation. Are you sure? Yes, no, or so on. There's various other dialogues that are commonly used. If you've ever used GIMP, the graphics editing tool, you'll know that pops up all sorts of dialogues to let you view layers and change colors or color pickers. If you used quite a few graphics tools have a dialogue that pops up and lets you do the eyedropper to select colors, and so on and so on and so on. I'm sure you all know what a dialog box is. Now there's another one which is less obvious, and you will only have known this if you've done any form of interactive programming on web, and that's called an applet. And an applet is a piece of code that runs inside a web browser. Now you might not, in fact you probably haven't really noticed the applet container class, because it'll all blend in, if you've done it well, it will blend in seamlessly with the browser itself. But it's still there. You'll have the web page all around the applet frame, or container I should say, not frame, container. So it's just something to bear in mind. This course doesn't really cover applets. I'm going to do another quite large section all about Java GUI, webs, applets, applet servers, and so on. I'll do another quite big section on that another time. But at least you know it's there. Now, whenever you use containers, you've got to keep a few things in your mind. It's very important. Every GUI component must be part of a containment hierarchy. Now, I've banged on a lot about hierarchy. I know I have, and if you've been following all of the course, you'll be sick to death of me going on about it. But hierarchy is, you start with the root, and that has something underneath that, that has something underneath that, and that has something underneath that, and so on and so on and so on. And it can build to tree, it can build just as a monolithic singular line. But every component must be part of a container. It has to be. Otherwise it has no real place to go, no owner, no way of receiving its event messages. It doesn't have anything really to do with the application. It'll just be a component. It wouldn't be part of the application. A top level container has to have a content pane. Pretty much think of that as the main part. Whether it's directly or indirectly, it may contain visible or invisible components, but it's the top level container. You can add, if you want, menu bars. It would hold the menu bar. That's quite a good example. And in Swing, I've mentioned before, you can conveniently change look and feel. That's one of the great benefits of using Swing. There's a Mac fill, there's a MS fill, there's a Xmotif fill. There's probably a whole load of other ones as well. That again tailors it to how the user experiences the containers and makes it look in a way that's familiar to them and pleasant for them to use. As a GUI designer, you should always be trying to put yourself in the user's perspective. Constantly ask yourself, if I was using this, how would it look and feel? How would it interact with me? How can I interact with it? Is that a pleasant experience, or is that something where each time I have to do this particular operation, I think, oh no. You get the idea. I'm sure we've all seen applications where you only use them because you haven't got a choice. There's another one which is a little bit unconventional. It's called the internal frame, J-internal frame. It mimics a J-frame, a J-frame being the topmost container frame, but they're not actually a top level container. They appear to be, but they're not. If you start dealing with internal frames, please keep that in mind and do your research to see exactly what you can and can't do. Remember, it's only mimicking a J-frame. It's not one. Earlier in the course, I spoke about Swing being hierarchical, and in this one I've mentioned hierarchy a lot. It's an absolute fundamental part of a GUI. I think I've said that a lot now, but I'll carry on saying it because you'd be amazed how many people seem to forget about that. As a general rule, a standalone Swing will have at least one hierarchy starting with a J-frame as its root. That's the convention. It's not always the case, but most of the time it is. As I've said, a standalone Swing application has at least one containment hierarchy. Applets also have at least one containment hierarchy, which is rooted by the JApplet object. For example, an applet that brings up a dialog has two containment hierarchies. The components in the browser window are in the containment hierarchy rooted by the JApplet object. The dialog also has a containment hierarchy rooted by a JDialog object. Now, it's pretty easy adding items to the content pane. You request a handle to it from the frame, use frame.getContentPane, and use the member .add. In this slide I'm adding a label, and I've requested that it be centered. Don't worry about the border layout. I'll cover layouts in a different section. It's easy to customize Content Pane, setting layout managers, adding borders, all sorts of other things. However, there's one tiny little thing you need to be aware of. The getContentPane method returns a container object, not a JComponent object. So if you want to use a feature of a JComponent, you must typecast it, and you should be familiar with that by the time you're at this level. The default layout for a JPanel is flow. You will almost certainly going to want to change that. Flows are good, but as the top level, probably not the best. I say we cover layouts in a lot more detail, but if you do want to customize it, there's a little bit of a code extract down below on the slide, and also there's a lot in the handout, so please do take a look at that if you particularly want to know about it at this moment in time. there's a convenient way of using the add and its variants. Remove. Set layout has been overridden to forward to the content pane as necessary. So this means it makes it quite nice actually, because we can just simply write frame.add and then give it the child, and that child will be added to the main content pane. So that's a nice little convenience that they've done for us in the library. But only these methods can do this. This means getLayout will not return the layout that you set with the set layout. You must be careful to remember that. So now we come on to the root pane. Every top level container relies on an intermediate container called the root pane, and the root pane manages the content pane and the menu bar, along with a couple of other containers as well, which you probably don't need to worry about. However, if you need to intercept mouse clicks or paint over multiple components, you'll need to get familiar with root panes to be able to get access to all of the ones that you want to access. So there are three main components: the menu bar, a layered pane, and a glass pane. The layered pane contains the menu bar and the content pane and enables Z ordering of the other components. I'll talk a bit more about Z ordering in a minute, but basically if you have multiple components on a pane, the Z ordering is the order in which they appear as though they're layered. So one on top of the other, on top of the other, on top of the other. And if you want to change them, you change the Z order number or reference of the particular object that you want to change. A glass pane is often used to intercept input events occurring over the top level container, and is also useful and is used to paint over multiple components. So if you think about it, if you've got a whole load of objects on various different layers and levels, the glass pane is over the top of them. So you can use that to paint. Think of it as like not an IT sense of the word window pane, but a window in a house. Okay, and you've got what's a whole load of stuff there, and you look out the window, you've got a whole load of stuff behind it, and if you want to obscure parts of it, you cover part of that window glass and you can't see what's behind it anymore. That's to relate. It's unfortunate that we're using the same names for things here, but it gives you the idea. That's probably actually where the people that came up with this got its name from. Normally it's hidden. You can make it visible, and as I've just said, think of it as a sheet of glass over other parts of the root pane. It's completely transparent, but you can draw on it. But to do so, you need to implement a method called paint component so that it does something. And it can also intercept input events for the root pane. So that's another way of getting access or manipulating things that go on within the root pane. So we've got an example in the handout, and also there's a NetBeans project which has quite a nice demonstration of what you can do with a glass pane. So please take time to go through it. It's too long-winded to cover in this video. That would make the video far too long, and it would probably not be of much use, as if you actually go through the code, run the code, put breakpoints in, look at how values change and events are captured and then handled. So please take some time out now to have a play around with that project and to go through the accompanying notes in the handout. A layered pane. It's used to position its contents, which consists of the content pane and the optional menu bar. Now, you probably know this already, but you probably never actually stopped to think about it. When you use a Windows app, you quite happily, I don't know if it's say Word or Office or something like that, you do all the bit in your working document and you move things around, and you can't just sort of drift them off into the menu. The menu is kept separate to the bit that you're working on. And so that's pretty much where the layer pane comes in that respect. And I mentioned the Z order, and I've put an official definition of Z order at the base of this slide. You don't really need to know it in too much detail, but if you've got overlapping objects and you're firing events off and you expect them to arrive in one object and they don't, they arrive in a different one, or they seemingly don't arrive at all, remember there's a Z order and take a look at the Z order to see whether the event that you're expecting that didn't arrive, maybe it arrived somewhere else. That's all you need to know about at this stage to deal with layered panes. Content pane, the container, the root pane, visible components, excluding the menu bar. Now, I've said that a few times as we've gone along, but just make it absolutely explicitly clear. Just remember that. To wrap up, layers are a vital part of a GUI. There are example uses of each type of layer which will become clear as the course goes on. You don't need to spend loads of time learning all about them now, because as we use them in other parts of the course, you'll just naturally see and assimilate what you need to know. So at this stage, all you need to do is just have an appreciation of them, and that's enough. Okay, don't get really fed up on putting loads of work into learning all about them. It will become obvious as you use them more and more and more, just by using your keen understanding of them. Okay, that's it for this section of the course. I hope you found it informative and useful, and please continue the course. Hopefully see you soon on the next part. Take care, thanks for your time, goodbye for now.